Okay, so we're going to look at a data table for uh, entering data in Microsoft Excel for the copper wire lab. Um, I've started entering information in here. Um, I've kind of set this up similar to what we discussed during the lab. The I just put table one, and I gave it a title, copper wire, and then whatever wire name that it was. Let's just pretend it's you know copper wire J. So we'll just say that that's what this sample is, which you did not do. Um, and I've entered a few length and mass measurements here. I've set my data table up with the column headings here. Um, and just ran however many samples that you're doing. Now, one thing is, if you just printed this off like this, it wouldn't show the lines unless you told it to. But you can separate that and put your grid lines in there. If you just say select probably this information, we'll start there, and you can go up here to your borders and just do all borders, and it'll put lines in between all of those. You can also do that for this part, and you'll have that kind of set up that way. So you could even do that, over here where you're be doing your error and that, and your percent error, and at the bottom where you'll enter your closest actual diameter and the AWG size, like that. And sometimes I even highlight certain things. I put little highlight colors in there, so maybe that's something that's going to stand out. Um, and I just pick a color and different colors, just because you'll be wanting to draw attention to certain parts. So I'm going to add some information in here from the textbook, which I'll just complete that whole citation. Witten, Davis, Peck, and Stanley. And if it doesn't show all of it, you can highlight some more cells like this and click merge and center. It'll show all of it that way. The first thing was the density of copper, which we'll represent with a capital D. And then if you'll type the symbol for copper, which is Cu for cuprum, I want it to be capitalized, copper. I'll fix that in a second. And from the textbook, it was in the unit of grams per centimeter cubed. So I'm going to just real quick talk about formatting your subscript that I want you to do for the copper and the superscript for the cubed. So if I highlight the CU part and I right click on it and click format cells, it'll bring up this where I can format the font. For that I want it to be underneath, so I'll pick subscript and click OK. And then again I want to make my capital C. Oops, I went one more time. There we go. And then highlight my 3, select that, right click, format that as a superscript, like that. And then I'll put, I may be outside that, a little asterisk like I did up there with that, just to say they go together. And that value was 8.92. I want to put that in its own little cell with no letters, so I can click in it every time I need to use that value. Another thing that you'll also have to use for the calculation, since it was involved the volume of a cylinder, would be the value for pi. So right next to this, I'll click in that cell, and I'll go to Insert, the top, symbol, and then I'll look under the subset mathematical operators, maybe, or I'd probably be under Greek actually. Greek and Coptic, and there it is right there, pi, lowercase small pi. There we go. So click insert and it'll be right there. I can center that by going to the home tab and centering that up. Now if I want to actually use the value for pi, so if you want Excel to put that in there for you, then you click underneath there and you type equals, and you type like just the word pi, and then open and close parentheses right back to back, equals pi parentheses, and there it is. And that's the value for pi, is all for like a long way out through there. So then anytime you need to use pi for calculation, you can just click that cell and tell it to always use that. The other thing that we might do is put the equation that we're going to use to calculate the diameter in centimeters. And it's a pretty easy step to go from centimeters to millimeters, but we might highlight the formula that we're going to use, the equation. So I'm going to just go to insert equation, and then it says type equation here. So it is diameter in centimeters is equal to, okay, so you have to remember what is it equal to. So the equation that we discussed once we derived everything else was 2 times the square root of, so I put the letter 2, then I need to go up here to my equation design tab, and I want to put a radical in there. So I'll just use the square root box, and then that itself was a fraction. So if I click in the little square here and I go to fraction and do that, now the top part was simple. It was just mass in grams, like that. The bottom part was a series of things. So I'm going to click in the little square, and I'm going to put me some brackets there, maybe like some square brackets or something. Doesn't really matter, but I'm going to use brackets inside of this, like parentheses or something. So I'll want to make sure that I enter everything. So it was equal to, on the bottom, the density, capital D, and that unit would have been parentheses script. It would have been, or let's see, first fraction, excuse me, fraction, density in grams on top. Click in the little bottom box, change that script to where you can do centimeters cubed. Centimeters in that part, cubed in that part. And use the right arrow to go over and then close that off this way. The density in grams per cubic centimeter times pi. You can just insert the pi symbol right there. So if you have your equation tab open, the pi letter is actually in these mathematical operators up here. And right there it is, pi times length and that was also in centimeters, and then all that's inside my brackets just like that. So this is my equation for calculating the diameter. So I take the mass in grams, divide it by whatever this product is right here each time, and multiply that by 2. So this ultimately gives me the radius, and then I double the radius, and the unit will be centimeters when we're done, and then double the radius, you'll get the diameter, and that'll be right here. So that'll just show how you get that in the calculation. So then, so I have a density in there, and then now density depends on temperature. So this is also very important. We'll discuss this later, but this density right here is, I believe that's 20 degrees Celsius. So, you know, you might say at just 20, and then you could go insert a symbol, and your I'm looking for your degree sign. I use it frequently, so it's right in the, it is under the subset Latin 1 supplement. Insert your degree sign, and then Celsius. Because it's like as you increase the temperature of the copper, its volume expands, and density actually goes down. So I think at like 100 degrees Celsius, it's like 8.8 something. So the temperature does matter for that. You could state that at 20 degrees Celsius, which is closer to the temperature of my lab. So anyway, so then you have that information, and then you're going to go over here and start letting Microsoft Excel do the calculations. So you're going to basically do this kind of stuff here to get it to give you the diameter in the cell, individual cell. So the way you're going to do that is you have to tell Microsoft Excel what to do with each part. So and how you enter this is going to matter. So I'm going to say, I might start out with the equal sign inside the cell. You need to do that first. And then you can say 2 times, and then you're going to have to do some parentheses, because you're going to have to multiply by the square root of all this stuff. So you type out SQRT, that's square root, and then you have to put parentheses. And then you're going to need another parentheses to start off right away. And then you're going to put mass for that particular one. So you click on that cell for that mass. Now close that parentheses and hit divided by, and then put another parentheses open. And then you want to get this part, which is density, pi, and length. Well, the density, that's why you want to make sure you have nothing but the number value here. You click on that, but you always want to use that number, that cell. So you hit this F4 button, and then times. Don't close your parentheses yet because you need to add the pi. And then also always use that one, so hit F4 again. And times this cell that it's not going to let me click in, so I have to type it manually. It is C6 and then close that parentheses and then close the parentheses again, and it gives you your diameter in centimeters. Now, sig figs, we got to look at what we have available. The density here, 8.92, has limited us to that 3 sig figs, because the length and the mass had 4, but our density had 3. But I can, so these zeros in the beginning are not significant. Now that 0 is significant, after the 4, but that's still only 2 sig figs. So I can increase the decimal one time. So I'll go to the Home tab and then increase decimal once. And then you have to stop there. And then what you can do is go to the right-hand corner at the bottom and drag that down for the other 3 measurements I've made. And then in the diameter in millimeters cell, you can type in equals that cell times 10. And again, you have to increase the decimal, keep your 3 sig figs, and drag that down. Okay, so so that way I can check and see if you typed in the formula correctly for each one. And now we can do the average in millimeters that I'm requesting here. So this equals, type out the word average, open parentheses, select the numbers, enter. And then the decimal places will stay the same, so increase the decimal. And then this equals the standard deviation equals STDEV, open parentheses, select the numbers, enter. Match up the decimal places. There is a standard deviation in between those, but it's very, very small. You can increase that. You can see that there's a 3 after it. You can leave that in there for just a second, and I'll show you what to do with that, how I want you to represent it. But that's kind of, it came out really small, standard deviation. But so you would say you report your experimental average for copper wire J diameter as 0.405, and then plus or minus. So we want to insert our plus or minus symbol, which is, again, I believe in mathematical operators. We probably would have that somewhere in there. Plus or minus 0.0003 millimeters. And then I want you to take that 3 and highlight it, right click on it, format cells, subscript, like that. And that shows that there is a digit there, but it's just not a significant digit. But it's there. But 0.405, that's your millimeter diameter. Okay? Now, you try to find out like what this is closer to on the Ted Palo Incorporated website, which is, you have the link on your lab handout. So, closest diameter, and it was said 0.405, 0.4, I'm looking in the millimeters column here, conductor diameter in millimeters, and I saw 0.40386. So that's the closest value. Corresponds to AWG 26. So I'm going to put the actual diameter was 0.40386 in millimeters, which was AWG 26. And my source for that is Ted Palo, Inc., let's just see if their website has a date on the page. Well, it's through 2016, so I'll just put 2016 for that. So that's where I got that information from. That's where you'll get that information from. And then, so according to your data, This is the average, or according to this data, this is the average millimeter thick or diameter, and this is the closest thing to it on the website, and that corresponded to gauge 26. That's where I got that from. Calculate how close the experimental value is to the actual diameter. I need to find the absolute value of the error right here. You can see the absolute value of the error is of the difference between your experimentally determined average diameter and the closest diameter from the Ted Palo website. Then you have to use sig figs when you do the subtraction, because that's what you're doing. Difference is subtraction. So this equals, well, it equals your 0.405 minus that, right? So you would type in equals absolute ABS for absolute value, number, this minus this, enter, and then the same number of decimal places as the least, because you'll notice that it says, you know, follow the rules for subtracting. So you need to go one more decimal place, so you need to increase the decimal for that. Wait, for this one. 0.001 decimal places, 3. Only one sig fig in that. Interesting. All right. So now we go to a new percent error, and you get this by dividing the absolute value of the error by the actual value, and then multiply by 100. So this cell equals, well, it equals the, open up parentheses here, and this number, the error, divided by the actual. So click on the actual down here, and then times 100, like that, and you get to have one significant figure. So increase, there you go. So that's a 0.2% error compared to that number there. Now you may be totally wrong. You're just analyzing based on the measurements and calculations, your average calculation, compared it to the closest thing you could find on there, and use that to predict the AWG wire gauge. And then this is when you compare it, this is the error between your experimentally determined value and your closest value on the website. It doesn't mean you're right. You know, I know what it was. I know what the gauges are for the wires you're working with, but you know, right now you may not know. So, but this will just give you an idea how to set up your Excel part, and you know, get that, you know, get good practice with that, and you know, using Microsoft Excel a little bit more. And then I'll show you in another video how to show these kind of sample calculations in a formal lab report. Also, remember that you'll do this twice. So if you do one of them completely through, and you've got different wire sizes, so you have to do another data table. So you'll have another one that says table 2, and then a copper wire K or whatever, and you'll do another table completely. Well, if you don't want to redo all of this stuff, you know, if you've got it once, then you can go down to the bottom tabs. You won't be able to see, my video doesn't pick up the very bottom of my computer screen, but the very bottom of the Excel page, there's a little tab that'll say probably sheet 1 unless you've renamed it. If you'll right click on that, you can see part of my menu right there, and I'm going to go up to where it says move or copy. I click that, and you can see this. I don't care if you move it to the end or not, wherever you want to put it. When you want to make a copy of this thing, you can, you know, I'll just say move it to the end, and I'm going to have to click create a copy right here. If you don't click that, it will not create one. So create a copy, and click OK. Then it'll open up that copy for you. This is the copy, right? This is the copy right here of that table. I'll show you. There's the copy. There's the original. Okay? So what you do then is you would just change this to table 2, change this to your new wire name, enter your new data in here in this part, and it should do all the, if everything's the same, it should do the calculations for you. Like if I change the length measurement to 25.56, everything changes right there. See, and it calculates all of it for you. After you've done it once, you shouldn't have to do it over. You just copy your tables as long as you're doing the exact same calculations. Okay, so good luck with that, and let me know if you have any questions.